Hello and welcome to this video. I was asked if I could actually explain how to write a function that will receive two parameters. The first parameter is going to be the base, and the second parameter is going to be the power. And as a result, we're going to return the value. For example, if I send 2 raised to the power of 10, usually we know this value, it's 1024, it's a kilobyte. So before we do anything else, in order to write a function, we have to come up with the prototype. The prototype tells me what this function is going to receive and what it's going to return, if it's going to return anything. Of course, this function is going to return something because it's going to return the base raised to the power. So let's go ahead and make this value big, like a long integer. I'm going to call the function expo, and I'm going to go ahead and in the prototype tell it that it's going to be receiving, when I do implement it down after the main function, it's going to receive two types of integers. So it's going to be receiving a value integer and another value integer. When I build a function, I'm going to do the same exact like the prototype without, of course, the semicolon at the end. But I have to name my variable here because these are going to be local to the function. Let's call this is B for the base, and this is P for the power. And when we write this function, B and P both are local to the function. The main function doesn't see them. We will be sending the values for P and B from the main function later in order to execute this function, and the function will return something. It's going to return, as you notice here, a long integer data type. So upon, we could go ahead and declare any variable that is going to be local to this function. Nobody going to see it but this function. If I say here long, let's say result, and that actually the variable is going to hold the multiplication, because you know exponent is a bunch of multiplication. I'm going to, of course, assign it to 1, because if I assign it to 0, everything will turn to 0. And the result is going to be multiplied in the left side, multiplied by the base. But this has to be done as many times as there are P. So we have to have a loop here, and I'm going to go ahead and declare a loop locally, integer I, and the loop is going to be done as many times as I less than or equal to the power. And of course we're gonna always, here we go, I deleted this by accident. So I is going to be 1, and it's, of course, semicolon, I less than or equal to P, and another semicolon, and I'm going to say here I plus plus. They have an extra parentheses, so we have to take that out, and I'm going to go ahead and put the brace here, push the result to indent it right here, of course put a semicolon, and that will accumulate for me the result. So I want you to take pencils and a paper and keep track of the value of I and the value of P, and B is going to be always the base, which is, let's say, 2 in this case. Let's assume P is going to be 10. And after the loop finishes, of course, we're going to return to the main function. We're going to return the value result. That is the variable that is going to hold all the calculation that we did in the loop. So the loop is going to be iterative. It will be iterating as many times as I less than or equal to B. In the main function, I could read the values or I could just assign them. It doesn't matter. Let's say here I'm going to say integer value 1, and let's say this is 2, and let's say value 2, and this is going to be 10. And I'm going to say also, I'm going to go ahead and declare a long variable, and I'm going to call it the my result or result, which is please to distinguish this is different from the result at the bottom, even though it's going to be the same because I'm going to send the value from the function to this variable result. But they are different variables in the memory because they are in a different scope, one in the main function and one in the expo function. So when I say here result is going to be assigned to the function expo, and I'm going to be sending value 1 and value 2. And notice here, if I do send those two, value 1 will become B, and value 2 is going to be P. I could call it here the full name base. It's better. Here we go. And I could call the whole thing here power. Okay. So if I call them there base and power, I'm going to change it here base. And I'm going to change it here to power. Okay. So, and you notice here, if I print this, say print F. Okay. Percentage 2D raised to the power. I'm just making this to look good. I use the exponent usually for exponents 2D. It's going to be equal to, of course, long integer is going to be LD. Let's go ahead and reserve 5 places for it, or even 10 places, just in case it got too big. Let's say here 10 LD. And we're going to go ahead and say this is comma here, the power, the base for the first value, the power, and the result. All right, so let's see if that's going to work. Then I'll explain to you how this is, and I hope it'll get me back. No, it lost it, no problem. It's going to be percentage 2D raised to the power of percentage 2D. It's going to be percentage, give me 10 spaces, LD, that is for the long, which is the result, and it's going to be base, here we go, base, comma, power, and of course result, here we go. Now let's run this and see how it's going to work. Okay. All right, I have a problem here. No problem. I go ahead and all right. Go ahead and say Control C, and I'm going to refresh the screen. That's basically what it is. Refresh the screen. I'm going to go ahead and paste it again, take the whole thing and run it again, and I have an error, syntactical error, not like that error, say here 4 with my rush here, I put FOR. Okay, that's an error. Let's see if we'll have any other error here. I'm sure I misspelled result. I could see it right there. Result. Okay. All right. Let's go ahead and run it again. Now let's see if this is going to work. See the result up there. It's working fine. 2 raised to the power of 10 is 1,224. If I change this to, let's say 20, that's going to give me a little bit over 1 million. Okay, and therefore it is working. So let's go ahead and explain a little bit what happens here with this, because it's very important for us to see what's going on with this one here. So let's go ahead and raise that a little bit. Beside the prototype, in the main function, that's where everything starts. The program starts executing in the main function. I have the base, a variable that is assigned to 2, power is assigned to 20. So long is a result. It's a variable that will actually receive a long value. I'm calling the function, it's called expo, and I'm sending the value of base, not the base itself, and I'm sending 20. So I must leave now the main function and go to the function expo Upon the arrival in Expo, I have handed B2 and I handed P20. Then inside the main in the local function, I declared another variable by the name results, which happens to be the same name. They have nothing to do with each other. I assigned it to 1. I declared also a local variable I, which never will be seen by the main function. Then I went for a loop that will be run as many times as I less than P, which is the 20 in this case. And every time the loop goes, it multiply the 1 by the base, which is in this case is 2, then it's going to be 2. The next time I is going to go next time, it's going to be result, which is in this case is 2 multiplied by 2, 4. Then 4 multiplied by 2 is 8. Then 8 by 2 is multiplied by 2 is 16. Then 32. Then 128, 256, and so forth. And of course, after the loop, and we have to go a little bit down here, as you will notice, after the loop, I have to return the result. I have to return the result. So I want you to see here, 1 second here. I'm going to go ahead and, all right, get out of here. No. All right, so let me go ahead and do this a little bit. And you could see that here, I'm returning the result. I'm returning the result so you could see it. Of course, I have a brace at the end there, so don't forget it to close the local function, but that's what it's going to be returned to the main function directly to here. So this is the value, it's going to come here. The result will welcome that value, and as a result, I will be able to print it locally. So whatever I send in the base, which is 2, the power, which is 20, the result was calculated in the expo function, and all the work was done there and returned to me, and therefore I was able to use it. So I could call this function as many times as I want with 2 values, as long as these values integers, and it's going to return for me a long value because the value gets too big with exponent, as we know. That's why I declare the return value as a long. Thank you for watching. I hope this has helped.